One of the important parameters that is considered during the antenna design is beam width. So in this video, we are going to explore more about it. Let's see what is meant by beam width. So if we consider the radiation pattern, we know that it has major lobes and lots of minor lobes. Suppose if we are separating this major lobe into two by an axis of symmetry like this, we know that it will look like a symmetric pattern because most of the antenna will be having some symmetric patterns. Some antennas will be having asymmetric patterns. So suppose our antenna is symmetric and I'm dividing this into two, and here you can see that on the opposite side we have identical points. So the angular separation between any two identical points on a radiation pattern is known as the beam width. So if I am considering this point, I have an identical point here. So this angular separation is known as the beam width. So I can take any point and can define the beam width. So for antenna engineers, there are two types of beam width is defined. First one is half power beam width and second one is first null beam width. So these are the main beam width that we'll be considering while designing the antennas. So in case of an half power beamwidth, when we are considering the radiation pattern and when it is normalized, the half power beamwidth from the name itself, it indicates that it will be considering the points where the power is reduced to half. So if we are considering the power in dB, the reduction will be minus 3 dB. So it represents the angular separation between the 2 points where power is reduced to 3 dB. So this is the normalized pattern. So we have a maximum power of 0 dB and half power means minus 3 dB difference, and when we extend this angular separation is known as half power beamwidth. So in the Cartesian coordinate also we can see the half power beamwidth, so that we have to find out the minus 3 dB point and extend and find out this angle difference. This will give us the indication about the half power beamwidth. So this gives an indication about the focusing power of the antenna. So if we have a very narrow half power beam width, it means that most of the power is mostly concentrated into the major lobe, and it will be having like high gain and can be used for longer distance point to point communication. That is the indication of half power beam width. That gives an indication about where it is a high gain antenna or not. And next parameter is first null beam width. So let's see what is meant by null. So here when we consider the pattern, we can see that there are some points where the radiated power is very small. So these points are called the nulls. So here we can see that there are so many nulls in between the minor lobes and the minor lobe and the major lobe. So if we consider the major lobe, these 2 points forms the nulls, first nulls. So the angular separation between these first nulls is known as first null beam width. So in effect, it gives an indication about the width of the main beam. That is full null beam width. So in the Cartesian coordinate also, we can see there are lots of nulls, and these are the first nulls with respect to the major lobe, and the angular separation between these two gives an indication about the first null beam width. So these are the two beam width we are considering while designing the antennas. Thank you. If you find any of these videos useful, kindly support by liking, commenting, sharing and subscribing. Thank you.